In this lesson, we want to review adding and subtracting polynomials. So before we look at our sample problems, we want to review the concept of like terms. So recall, when you're adding and subtracting polynomials, you need to be able to combine like terms. So first and foremost, what are like terms? Well, if I have only one variable involved, like terms have the same variable raised to the same power. So something like 2x squared and 5x squared. We have the same variable. We have an x and we have an x. And we also have the same exponent. So we have a 2 and we have a 2. So these are like terms. These are like terms. Now, if I saw something else, let me kind of scroll down a little bit. We'll get back to that picture in a minute. If we saw something else like, let's say, 3x squared and 5y squared. These are not like terms. You have different variables. You have a variable of x and you have a variable of y. The exponent is the same, but that doesn't matter because the variables are different. So those are not like terms. So we can say not like terms. And to give you another example where we don't have like terms, suppose we had 5x to the 5th power and let's say 7x to the 4th power. We have the same variable. You have x and you have x, but the exponent is different. You have an exponent of 5 and an exponent of 4, so these are not like terms. Okay, so let's erase this real quick. And I'm going to leave this example up here because we're going to work with it in a second. And I want to talk a little bit about like terms with more than one variable. So this can be a little bit challenging to describe with words. So let me kind of give it my best shot. So essentially what you're looking for is the exact same variable parts, okay, plural. So each variable that you have has to be present in each term. So if you have an x and a y in one term, you have to have an x and a y in the other term. If you have x, y, z in one term, you got to have x, y, z in the other term. Then each variable, okay, that's similar has to be raised to the same power. So what I mean by that is if you have x that's squared in one, you've got to have x squared in the other. Okay, so you got to have the same variables and they have to be raised to the same power. Not all of them raised to the same power, but the x has to be raised to the same power as the other x. The y has to be raised to the same power as the other y. Okay, so as an example, suppose we had 2xyz squared and we had 5xyz squared. Now, I have an x, I have an x. I have a y, I have a y. I have a z, I have a z. Remember, when we don't have a visible exponent, we can say it's an exponent of 1. So I'm just going to fill these in real quick for reference sake. So we have x to the first power and x to the first power, right? Same exponent. Y to the first power, y to the first power, same exponent. Z squared and z squared, same exponent. So I'm not saying the exponent has to be the same on all the variables. What I'm saying is that if you have a z squared here, you've got to have a z squared over here to have like terms. Okay? If you had, let's say, a y cubed here, this guy over here would have to be y cubed for you to have like terms. If you had an x to the, let's say, 7th power, then this guy over here would have to be x to the 7th power to have like terms. The coefficients or the numbers that are multiplying the variables or variable never matter. Okay, it doesn't affect anything when you're talking about having like terms. It's only the variable parts that matter. So these would be like terms. So as an example where you don't have like terms, suppose you had 13x to the 4th power y squared, and then something like 9x cubed y squared. So you have an x and you have an x, you have a y and you have a y. So the variables are the same. You have x and y. But the exponents are not the same, right? So here you have x to the 4th power, here you have x cubed. So right there you can stop. It fails, you don't have like terms. Although you have y squared here and y squared here, this guy right here is what stops you, okay, that 4 and that 3. If I change this into a 4, then I have like terms. If this gets changed back into a 3, I don't have like terms, okay? So once you understand the concept of like terms and what you're looking for there, you're ready to move on and think about how to combine like terms. Okay, so let's start out with just addition. And I'm going to kind of scroll up just a little bit, and I'm going to show you a few different things. And I'm going to show you with a little illustration that often helps students that struggle with this concept. So if we have 2x squared and 5x squared, we can sum these using the distributive property. So before I even do that, let me just tell you it's very, very easy to find the sum. You just add the coefficients. If I have 2 of something plus 5 of the same thing, it's 7 of that thing. So I have 7x squared. But if you can't wrap your head around that at first, use the distributive property. So if I had 2x squared plus 5x squared, we know at this point that we can use our distributive property and we can factor out the x squared. So we're going to pull this out in front of a set of parentheses. And inside I'd have the 2 plus the 5. So if I did 2 plus 5, that's 7. So this ends up giving me 7x squared. So that's kind of 2 different ways you can think about this. Another way to think about this, and kind of erase everything. If you think about 2x squared plus 5x squared like this, 2x squared is what? It's x squared plus x squared. Okay, this is 2x squared. Then plus 5x squared is x squared plus x squared plus x squared plus x squared plus x squared. 1, 2, 3, 4, 5 of those guys. So if I have, again, 2 of something plus 5 of the same thing, I know I'm going to have 7 of that, right? If I just went through and dropped the parentheses and said x squared plus 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 x squared, I'm going to have 7x squared, okay? So there's a few different ways you can kind of think about this. Now, I want to turn to this kind of image I have up here, and this is something that really gets students thinking. If you ever can't figure out why you can't combine like terms, you can go to this simple example which is taught in pretty much every Algebra 1 course. So you think about having apples and oranges. The apples you can think of as being like terms with each other, and the oranges you can think of being like terms with each other. So in other words, if I have 4 apples here and 2 apples here, I can combine these two and say I have 6 apples. Okay, very easy. If I have 2 oranges here and 1 orange here, I can combine these and say this is 3 oranges. Now, what do I do here? I have an apple and an orange plus another orange. Can I combine everything here? No. All I can do is add the orange and the orange. I would have to say this is 1 apple and, or you could say plus if you wanted to, 2 oranges. The orange and the apple are different. You can't combine them, right? I mean, you can put them together, but you don't combine them like you would if you had all apples or all oranges. So you have to say you have 1 apple and 2 oranges. It's the same thing if you had something like 3x plus 5x squared plus 2x squared. We know 5x squared plus 2x squared is 7x squared. So we would have 7x squared plus 3x. This right here, I can't combine this any further because they're not like terms. I have 7 of some quantity, x squared, plus 3 times a different quantity. So I basically have 7 apples and 3 oranges here. Okay, so I just got to list it as 7 apples and 3 oranges. I can't really make it any simpler, so that's why we write 7x squared plus 3x. All right, so now that we understand the concept of like terms and how to combine like terms, let's talk about how we're going to add polynomials. So adding polynomials is very, very simple. You're just going to drop the parentheses, okay? You can add in any order because of the commutative property. The easiest thing to do is just to put your like terms next to each other, and then you're going to combine all the like terms you can, and then you want to place your answer in standard form, okay? So for this one, I'm going to just write 3x squared, okay, that's this one right here, plus, do I have any other terms with x squared? I have this guy right here, so 19x squared. Then plus I have 2x and 7x, so 2x plus 7x, then plus 5 plus 1. And what I like to do is just put a little dot above everything to show that I've used everything. Just a little technique I use. Of course, you can do whatever you want. Now, once I've written it this way, notice how my like terms are next to each other. So I can go through here and say, well, 3 plus 19 is 22. The x squared would come along for the ride, right? So 3x squared plus 19x squared would be 22x squared. And plus 2x plus 7x, that would give me 9x, right? 2 plus 7 is 9. Then plus 5 plus 1, we know that is 6. So this is as simple as we can make this because none of these are like terms with each other, okay? So we have 22x squared plus 9x plus 6. Now, another method you can use, another common method that you will see, and this would work also, is to use a vertical addition method, just like we would use when we're adding multi-digit whole numbers. So the idea here is to line it up by like terms. So you could say 3x squared plus 2x plus 5. And this one will line up perfectly for us. So we'll put plus 19x squared plus 7x and then plus 1. So I'm just going to add in these columns here, okay, these columns. If I go straight down, 5 plus 1 is 6, 2x plus 7x is 9x, and 3x squared plus 19x squared is 22x squared. So either way you want to do it, you get the same answer. I find horizontal addition is a little bit faster because a lot of times I don't end up even writing things out. I just kind of eyeball things. And I'll say, okay, well, 3x squared plus 19x squared is 22x squared. I'll just write that down, kind of put a dot over it to say I've used it, and kind of move on. So now let's talk about subtracting polynomials. So there is an additional step involved in this process. I want you to think back to when we did 5 minus 3, and we wrote this as 5 plus a negative 3. Remember, you can always change a subtraction operation into addition of the opposite. So instead of 5 minus 3, I can say 5 plus negative 3. Well, that's exactly what we're going to do here. We're going to change our subtraction operation to addition, and we're going to change the polynomial that's being subtracted away into its opposite. How do you change something into its opposite? You multiply it by -1 or you change the sign. So I can just put plus -1 here, and you're going to see this in a lot of your classes. You'll see this plus -1 outside of parentheses, and you're going to wonder, why do they keep doing that? The reason they do that is to remind you that you need to distribute a -1 to each term here, and that's going to change the sign of each term for you, and then you can just add once you've done that. So if we go through and do this, the first polynomial here, I can just drop the parentheses. I don't need to do anything. So 7x to the 5th power minus 3x minus 11. Now I want to change the sign of each term by distributing my -1. So -1 times -9x to the 5th power would be plus 9x to the 5th power. -1 times 9x would be minus 9x. -1 times 4 would be minus 4. And once you get really good at these, what you can do is just change it in here, right? You can just change it as you're working the problem, and it's a little bit quicker, right? It's the same either way. Once I've done this, I can just drop the parentheses, and I can just go through and do my addition. Remember, you can add in any order, and you can also relate subtraction to addition of the opposite. So if I have minus 3x, I could say that's plus -3x, right? So I could rearrange things in any order that I'd like using that technique. So what I'm going to do is I'm just going to add on the fly here. I'm not going to rearrange stuff. I see that my highest exponent is a 5. So I'm going to start with that so my answer ends up in standard form. So if I have 7x to the 5th power and 9x to the 5th power, those guys are both going to be like terms. You have positive 7x to the 5th power plus positive 9x to the 5th power. That's going to give me 16x to the 5th power. So I've used those. Now I'm going to look for the next highest exponent. That's going to be a 1. So you have minus 3x and you have minus 9x. So you can basically think of this as plus -3x and plus -9x. So if I have those, -3x plus -9x is going to be -12x. So we can write this as minus 12x. Then lastly, we have minus 11 and minus 4. Again, you could write this as plus -11 and plus -4. So you could say -11 plus -4 would give me -15. So I can write minus 15 here. So we end up with 16x to the 5th power minus 12x minus 15. The answer is in standard form, and there's no like terms here that I can combine anything with. So this is as simple as we can make this. All right, let's kind of turn the heat up a little bit, and we'll look at not only a mix with addition and subtraction, we're also going to involve two variables now. So we have 14y to the 4th power minus 11x squared, then minus, we have negative 14y to the 4th power minus 7x squared, then plus 10x to the 4th power y to the 4th power, then plus, we have 9y to the 4th power minus 8x to the 4th power y to the 4th power. Okay, so this guy right here, nothing to do there other than just drop the parentheses. So I'm going to start by just writing 14y to the 4th power minus 11x squared. Okay, and if you want, a lot of people are more comfortable just putting plus negative, and you can leave it like this, or you can put the minus in front. Doesn't matter. Okay, so now we have this minus that's out here, And it's meant to be directly in front of this guy right here. We just don't have enough horizontal space on the screen to do that. So I'm going to put plus here, and I'm going to put a -1 here. And we're going to scroll down. And I'm going to distribute the -1 to each term. And that just means we're changing the sign. So I'm going to change the sign of -14y to the 4th power. It's plus 14y to the 4th power. Change the sign of -7x squared. It's plus 7x squared. Change the sign of 10x to the 4th power y to the 4th power. It's negative, or you could say minus 10x to the 4th power y to the 4th power. Again, you could write minus, or you could put plus negative. It does not matter. Okay, so now we have plus this guy, so I can just drop the parentheses. So 9y to the 4th power minus 8x to the 4th power y to the 4th power. Okay, scroll down and get some room going. Now, the highest power here is not so straightforward because you have multiple variables. So let's just add in the order that they come in, and then we'll show you how to put this in standard form. It's something we talked about in the last review lesson, but in case you missed that, we're going to show it again here. So if I start with 14y to the 4th power, I've got this guy right here, I've got this guy right here, and then I've got this guy right here. So 3 of those guys that can be combined. So you would do 14 plus 14, which is 28, and then 28 plus 9, which would give me 37. So this would be 37y to the 4th power. Okay, for the next one, I have -11x squared. I have 7x squared, and that's all I have there. So -11 plus 7 is -4. So we can put minus 4x squared. And then lastly, I'm going to have this guy right here, this -10x to the 4th power y to the 4th power, and -8x to the 4th power y to the 4th power. So -10 minus 8, or -10 plus a -8, if you wanted to write it like this, again, doesn't matter, you would get -18, right? So -18x to the 4th power y to the 4th power. So this is a valid answer, but again, we generally want to write things in standard form. Now, when you have multiple variables involved, it's generally going to be more acceptable to not write it in standard form because people tend to just leave their answer and kind of move on. If you have an answer with one variable, you should definitely make sure to put it in standard form. If you have multiple variables, in a lot of cases, it's not going to be looked at. But just so you know how to do it anyway. So the way we want to do this is by degree. Okay, that's the first thing. So this term right here has a degree of 4, right? Because you have an exponent of 4. This one has a degree of 2 from the exponent of 2. And this guy, we sum the exponent. So 4 plus 4 is 8. So we don't have anything that's conflicting here. It's straightforward. We'd have 8, then 4, then 2. So we're going to write it in that order. So we'd start with -18 x to the 4th power, y to the 4th power. Then we would put plus 37 y to the 4th power, and then minus 4x squared. And I know you might put this into one of those online calculators and get a different arrangement. Again, this is the proper way to do it. It might have a different formula or a different way to calculate it. When you work with one variable, there's a standard way. When you work with multiple variables, there's some different things that are going around. All right, let's take a look at one more problem. And then you should have enough review on this to be able to tackle pretty much any problem that deals with adding or subtracting polynomials. Very, very easy concept overall. So we have -12x cubed y plus xy to the 4th power. Then plus, we have 10x squared y cubed plus 10x cubed y minus 10x squared y squared. Then minus -3x cubed y minus 5x squared y squared. Okay, so the first guy right here, we could just drop the parentheses. So I'll put equals -12x cubed y plus xy to the 4th power. Okay, then this guy I have plus this. So because of that, I can just drop the parentheses. So we'll put plus 10x squared y cubed plus 10x cubed y minus 10x squared y squared. Then I have my minus. So I'm going to change that to plus, and I'll put my -1 here. And I'm going to distribute the -1 to each term, and that's going to remind me to change the sign of each term inside of the parentheses. So if I change the sign of this, it would be positive or plus 3x cubed y. If I change the sign of this, I'd have plus 5x squared y squared. Okay, so let's scroll down, get a little room going. And what we can do here, again, let's just go in order. So I have x cubed y. Do I have that again? I don't have it here, not here. I have it here, not here. I have it here, and not here. So I would have negative 12 plus 10, which is negative 2, then plus 3, which is 1. So this would be 1x cubed y, or you could just write x cubed y. All right, then next we have xy to the 4th power. Is there any other xy to the 4th power? No. So let's just put plus xy to the 4th power. And then we have x squared y cubed, and nothing else with that. So plus 10x squared y cubed plus. Lastly, we have negative 10x squared y squared and 5x squared y squared. So these are like terms. Negative 10 plus 5 is negative 5. Instead of putting plus, let me put minus. So we'll put minus 5x squared y squared. Now, the reason I wrote this example is to give you one where you have a little bit of trouble writing this in standard form. If you look at the terms here, this one has a degree of 4, right? You have an exponent of 3 and an implied exponent of 1. This one has a degree of 5, an exponent of 1, an exponent of 4. This guy has a degree of 5, right? 2 plus 3 is 5. And then lastly, this guy has a degree of 4. So you have 2 with a degree of 4 and 2 with a degree of 5. So what do you do? Well, what happens is when the degree is the same, we go in alphabetical order. So I'm going to look for the x, okay, because x comes before y. I'm going to look for the x with the largest exponent. So if I start with a degree of 5, this guy has an x raised to the power of 1. This guy has an x squared. So this is going to be my winner. So that's going to be the leading term. So 10x squared y cubed. Then this guy, so plus xy to the 4th power. So I've dealt with these ones that have a degree of 5, and now I'm going to think about what has a degree of 4. This one has x cubed, and this one has x squared. Again, I'm working in alphabetical order, so I'm thinking about the x, because x comes before y, with the higher exponent. So I'm going to go with this one. So I'm going to say plus x cubed y. And then lastly, I'm going to have minus 5x squared y squared. Okay, so don't let that type of problem trip you up. Essentially, when you have the degree that's the same on more than one term, you go in alphabetical order. So in this case, it was x and y. So we looked for x because x comes before y. And we looked for the x that had the larger exponent. Okay, so that one's going to win and go in front.